Okay, so this is lecture 2 of basic calculus 1. In the last lecture, we had discussed about the real line, then the intervals and neighborhoods, interior points and the left and right endpoints of intervals. So, this lecture we will be discussing about the absolute value. For every real number, it has an absolute value. That is what we will be discussing today, and then its use in finding out how the neighborhoods look like in terms of this absolute value and so on. Okay, so, let us start with the definition of the absolute value, which is also called the modulus. Suppose x is a real number, then its absolute value is defined this way, that if in two cases, if the real number x is greater than 0 or equal to 0, we will tell that the absolute value of x is equal to x or mod x equal to x, and if x is negative, it is less than 0, we will say that the absolute value of x equal to minus x. What does it really say? Suppose x equal to 1, then its absolute value will be equal to 1, and if x equal to minus 1, then its absolute value equal to minus of minus 1, which is again equal to 1. So, this absolute value really finds out the distance of the real number from 0 on the real line. Suppose you take the real line, you have 0 here, you take x here, which is positive, then the absolute value of x will be equal to x, which is equal to this distance itself. And if it is negative, say here it is say minus y, then its absolute value will be equal to y. So, minus y means something like minus 3, where 3 is positive. So, here minus y is positive, minus y is negative, so that is why it is here. Then its absolute value will be distance from this point to 0, which is again equal to y. So, that is how it will be used, and then we can of course write in different ways. For example, we can write mod x equal to square root of x square. So, whenever we have this symbol square root, it is always non-negative square root of that, because once you say x square, for example 9, its square root can be 3 or minus 3, but this symbol square root symbol, this one, that says you have to take the non-negative value. If it is 0, you have to take 0 anyway. If it is positive, then this result should be positive. So, we can write mod x equal to non-negative square root of x square, which is also equal to maximum of both these values x and minus x. Because suppose x equal to say 1, you get maximum of 1 and minus 1 as 1, and if x equal to minus 1, you get maximum of minus 1 and 1, which is 1. That is what the modulus means. So, these are another some two different ways of writing mod x. We can really graph it. Suppose we take x is positive, then mod x will be also positive, and say on the y axis we write mod x, on the x axis we write x. Then when x is positive, y equal to mod x will be equal to x. That is why you get the straight line on the right side. On the first quadrant you get the straight line, which is y equal to x. That gives the graph of mod x. And on the other side, y will be equal to minus x, because y is say mod x and x is negative here. So, mod x must be minus of x, then it should be equal to minus x, and it is the line y equal to minus x. So, this is how we will be plotting the value of mod x with respect to each x. Okay. So, now we will see some properties of this absolute value or mod. So, first property is a is less than or equal to mod a. That is very obvious, because mod a is equal to maximum of a and minus a. So, whatever it is the maximum. So, a must be less than or equal to that. Next we have mod A equal to A if and only if A is greater than or equal to 0. How does it come through? See, mod A can be either equal to A or equal to minus A. It is A when A is greater than or equal to 0, and when it is minus A, then A must be less than 0. That is what it says. So, on the other side we would say the way that mod A equal to A if and only if A is greater than or equal to 0. Similarly, if it is less than 0, you get mod A equal to minus A whenever A is less than 0. But another point included here is A equal to 0. At 0, let us see the modulus from the definition. Mod 0 equal to maximum of 0 or minus 0, anyway it is 0. So, also we can include equality symbol here, mod A equal to minus A if and only if A is less than or equal to 0. Next, by using these two, you see that whenever A equal to 0, its mod is equal to 0, from the definition it follows. But the other side, suppose mod A equal to 0, we have to show that A has to be equal to 0, A cannot be anything else. Okay, let us see if mod A equal to 0 is given. Now, this mod A can be either A or minus A, and in either case it is 0. So, that means A is 0 or minus A is 0, in any case A must be equal to 0. And this is very nice property, because sometimes we want to show that A is equal to 0, but it is not direct. We can go for its mod and show that mod A equal to 0, that will prove that A equal to 0. We will see such cases later. Now, the next property is very obvious, it is mod of minus A. Anyway, mod is the distance from the origin. So, A distance from the origin or minus A from the origin, they are same, minus of A mod must be equal to A mod, and also from the definition you can get directly. Well, how does it fare with the multiplication? If you take A times B and take its absolute value, it will be equal to mod A into mod B. This is not very quick from this, but if you take the square root, it will be easier to see, because mod AB will be equal to square root of A square B square, and that you can write as square root of A square into square root of B square, which gives you the right side. And if it happens for this multiplication, instead of B, had I taken 1 by B, where B is non-zero, then I would reach at this mod of A by B equal to mod A divided by mod B if B is non-zero. So, these are very easy properties, but they are important and they will be used most often without telling that these properties hold, they will be used implicitly. So, that means we should be getting very familiar with them. Okay, there is another we have done for the multiplication. How about addition? If you take mod of A plus B, it is less than or equal to mod A plus mod B. It may not be equal always, sometimes it is equal, but sometimes it is not. For example, if you take one of them to be positive, one of them negative, say A is 2 and B is minus 1. So, on the left side you get A plus B equal to minus 1 mod, but on the right side you get mod 2 plus mod 1, which is 3. So, it can be less also, specifically when they have opposite signs. Now, if they have the same sign, of course, that is either both of them are to the right of 0 or both of them are to the left of 0, then what happens? So, you can take mod A plus B, like say 2 plus 3, which is 5, its absolute value is also 5. On the right side you get mod 2, which is 2, plus mod 3, which is 3, that is also 5. Similarly, for the negatives. But how do you show that for all real numbers A and B, mod A plus B is less than or equal to mod A plus mod B? Well, let us use that square definition. So, let us take the square of the left side and we will see how to manage the square of the right side. Okay. So, A plus B mod square equal to A plus B whole square because of the square root, and now we expand it, which is A square plus B square plus 2AB, and we know that mod of A square equal to mod A into mod A, which is mod A square. Similarly, B square equal to mod B square, and we keep 2AB as it is and then use another properties of 2AB. this FB can be thought of as less than or equal to mod A into mod B. It is really equal, but can it be less? Yes, because we are not taking absolute value of this. We are using here x is less than or equal to mod x. So, AB here AB is less than or equal to mod of AB, which is equal to mod A into mod B. That is what we are using in the next line. So, this expression mod A square plus mod B square plus 2AB is less than or equal to mod A square plus mod B square plus 2 into mod A into mod B, and that gives us mod A plus mod B whole square. Now, once this x square is less than or equal to y square and both of them are non-negative, x must be less than or equal to y, and that gives us the triangle inequality mod A plus B is less than or equal to mod A plus mod B. Now, we have something called reverse triangle inequality, which is not exactly triangle inequality, but looks like that. So, here what we do, instead of plus we are taking minus, but the inequality is also reversed here. You see, absolute value of A minus absolute value of B and their absolute value is less than or equal to absolute value of A minus B. Of course, we can use the triangle inequality for proving it. So, let us start. We start with A, say mod A. So, inside that modular sign we subtract 1B and add 1B. So, they are equal. Then now use the triangle inequality to get A minus B as one factor and B is the other one. So, it is less than or equal to mod of A minus B plus mod B. So, that gives mod A minus mod B is less than or equal to mod of A minus B. Now, if you reverse the role of A and B, you would get the other inequality, that mod B minus mod A is less than or equal to mod of B minus A, and that mod of B minus A equal to mod of A minus B. Therefore, in any case we get two inequalities now, mod A minus mod B less than or equal to mod A minus B, mod B minus mod A is less than or equal to also mod A minus B. But what about the mod of mod A minus mod B? It is either mod A minus mod B or mod B minus mod A. So, in any case the absolute value must be less than or equal to mod of A minus B. That is how we have shown reverse triangle inequality. You can also square them both the sides and follow as we have done in triangle inequality, that will be an alternative proof. Okay. So, let us see how this absolute value play with the intervals. In fact, they would give rise to the neighborhoods, and let us see how. So, suppose we fix two real numbers x, a, and then take another positive number delta. So, delta is greater than 0. So, what it says that mod x will be equal to delta if and only if x equal to either delta or minus delta. That is obvious from the geometry. If you think of the real line, you take delta is positive. So, here is delta, then mod delta, or you say x mod equal to delta. So, that means this delta could have been like mod of delta equal to delta, and mod of minus delta is also equal to delta. So, one side is clear, if x is equal to delta or x equal to minus delta, then mod x equal to delta. What about the other side? That if mod x equal to delta, then x has to be equal to plus delta or equal to minus delta. That is clear from the definition, because if you take mod x, it is either equal to x or equal to minus x, and that is equal to delta. So, if x equal to mod x equal to x, then you get x equal to delta. If mod x equal to minus x, you would get minus x equal to delta or x equal to minus delta. So, these are the two possibilities, nothing else is possible. In fact, if you take any other x, say x is less than 0, its modulus will be less than delta. If it is bigger than, it will be, its modulus will be bigger than delta. Similarly, on the other side, if you take any x between minus delta to 0, its mod will be less than delta. If you take anything bigger than that or the left of minus delta, then its mod will be again bigger than delta. So, that is how this goes through, that is mod x equal to delta means only we have two possibilities, either it is delta or it is minus delta. Now, that goes for the equality. If it is less than, then what will happen? So, again you go back to your drawing and I have 0 here, I have delta. Now, x is a point such that mod x is less than delta. So, that means distance of x from 0 is less than delta. So, x can fall here or x can fall here, where this is minus delta. So, that means x can be anything between minus delta to delta. That is what the other side is telling, that mod x is less than delta if and only if minus delta is less than x is less than delta. That means x belongs to the delta neighborhood of 0. This is really the delta neighborhood of 0. So, it says that mod x less than delta is equivalent to telling in another way that x is an element of the delta neighborhood of 0. That is what we express by telling x belongs to minus delta to delta. Well, if it is instead of less than, it is less than or equal to, that means we are now combining both 1 and 2, then of course, the result will be combined again. It can be minus delta to delta, or it can be equal to delta or equal to minus delta. So, all these things are possible, which means it is the closed interval, that x belongs to the closed interval minus delta to delta. And now, suppose it is bigger than delta. So, that means we have to look at its complement, that x should not belong to minus delta to delta, or in other way, that if mod x is bigger than delta, this is your delta neighborhood, then what will happen is, if mod x is bigger than delta, then it is not possible as it is delta, it is not possible here, x has to lie here somewhere, this side, and x must lie in also this side, that is also another possibility. So, either minus delta is less than x or x is bigger than delta. That is what we express here, and it is just the complement of the closed interval, which we can write x belongs to minus delta to minus delta, minus infinity to minus delta, union delta to infinity. Just the complement of closed interval minus delta to delta. Okay. So, what about when mod x is greater than or equal to delta? Just we have to include the delta now. So, that means in the complement, when we are taking minus delta to delta closed interval, we will now be taking complement in the open interval. So, that is how we will get, it will be a semi open interval, the minus delta is included, delta also is included, that is it is R minus the delta neighborhood of 0, x can be anywhere in that set. That is what we mean by mod x is greater than or equal to delta. So, now let us slightly shift our origin. Instead of considering from 0, let us consider from the point A, which is also a real number. So, that means we have somewhere A, and we are now thinking that the number x minus A, x minus A mod will be less than delta. So, what does that mean? Now, instead of mod x less than delta as in 2, we are thinking mod x minus A is less than delta. So, as earlier, it will be translating, that origin will be shifted to A now. So, we can think of minus delta here, delta here. So, this point is really A plus delta, this point is really A minus delta. So, that means as earlier it is within that delta neighborhood, this is also delta neighborhood of A. We would get x minus A mod less than delta if and only if A minus delta is less than x is less than A plus delta. So, it is just another way of telling that x is an element of the delta neighborhood of A, x minus A mod is less than delta, that is what it means. Okay. So, now suppose it is less than or equal to delta, then that point equality will be introduced to both the sides. Instead of the open interval, it will be closed interval. So, x belongs to the closed interval A minus delta to A plus delta, and if it is greater than delta, the same x minus A mod is greater than delta, then it will be the complement of the seventh one, that it cannot belong to the closed interval A minus delta to A plus delta. So, either to the left of A minus delta or to the right of A plus delta, that is x is less than A minus delta, or it is possible x is greater than a plus delta. So, that is how it will look. We may say it is minus infinity to a minus delta union a plus delta to infinity. So, it is really a minus delta, x can be here, or x can be here, which is a plus delta, x can be here, whereas this is a and this distance is delta. Okay, that is how it will, the inequality x minus a mod less than delta gives rise to. And if it is greater than or equal to delta, then the point delta will be included and we will get the semi open intervals. X must be in minus infinity to a minus delta, where a minus delta is included, and on the other side also a plus delta can be included. So, these are various ways of interpreting the absolute value with inequalities. So, finally, one thing is enough to remember. If you can remember this one, that will give rise to other things by inclusion of a point or the other ones, and also the earlier cases can be explained through that by taking specifically a equal to 0. So, it says that x minus a mod less than delta is same thing as telling x belongs to the delta neighborhood of a.